I welcome you all to our this month session of the Battery Spotlight. I'm really happy that so many of you found the time again to join our monthly event. And before we start, I want to give a short introduction why we set up this event. With this event, we want to give companies through all of Europe the chance to present their innovations here and to get visible and to spark interest with their short pitches. We then encourage you all to connect yourself with these companies, and we therefore hope that this format is one puzzle piece to start collaborations, to start projects, not only in Germany, but throughout all of Europe. Because our overall goal is to transform what you can see on the left-hand side, Europe, but with a lot of different separated battery value chains. And we want to transform this into one joint European ecosystem. That is an important task. And of course, we are only playing a small part in this, but I hope that this is helping. For those who attend this meeting for the first time, let us quickly introduce ourselves. My name is Dr. Maximilian Wagner. I'm the network manager of TraWeBa. TraWeBa is a battery cluster funded by the German government with the goal to support all companies along the whole battery value chain in Germany to connect with themselves and to help them reach out to Europe to start international collaborations. And I'm really happy to have again with me here my collaboration partner and co-host Simon Voss, who is tackling this goal of getting one European battery ecosystem in his own and really innovative way.
Yeah, so also hello from my side. I'm really glad to be able to co-moderate this. As you maybe know, I'm the guy with the car touring through Europe, understanding who has the competence to build the European battery ecosystem. And I think the same goal holds for the Battery Spotlight event that we host today. And yeah, looking forward to what's coming.
All right. Before we start with the speakers and to give everybody a chance to still join our meeting, we have planned another format, which has the same goal to get this European battery ecosystem online, but that is from another angle. And Simon, maybe you want to comment on this, what we are planning, not only regionally, but in cooperation with the Volta Foundation as well.
Yes, thank you for handing over again. So on the expedition, what I saw is that there's a lot of technological potential, but the question is how we bring this to market. And I think understanding the customer and investor side, and Max, maybe you can go to the next slide. So what we're talking about is to understand who are also the investors in the space of the battery industry and who are the companies, and then find matches in order to initialize and initiate projects that can actually bring us closer to market adoption, right? Ramping up technological potentials all the way along the TRL scale. And this is what the Battery Investors event is for. So it's a one-day event that we will now, in collaboration with Volta, this battery expedition campaign that I launched, as well as TraWeBa, bring together investors as well as young companies in order to talk about and hopefully kick off some serious discussions on projects that can leverage the innovation potential those companies have. So don't want to talk too much about this here, but I just wanted to create the awareness of that, and we'll just post a link into the comments if you're interested in bringing your company to this event and have an opportunity to talk to interested investors. Then please hit the link and fill out the form that is in this on our landing page, and then have the potential or the opportunity to attend this exclusive event. So some advertisement on that, but I think it's also supporting our industry. And therewith, I invite you all, and maybe seeing you there in Berlin on the 4th of May. Good. With that, I think we can hover over. Max, you can share your screen again and talk about today's pitches.
Exactly. So you should see my screens again. And yeah, I think this like investment is really important because what two things which we need right now is first to build up the trust and the competences we have in Europe, and also to get the money to actually prove that we have these competence and these competences can work. And yeah, these two problems are depending on each other in a way. And yeah, we are really looking forward to this event. But with this, enough is said about us and what we are planning. And we are here to see the innovation happening right now in Europe. And with this, I want to give you a short overview of our lineup we prepared today for you. And we will start with Benjamin, talking about the importance of the smart charging when thinking about batteries. And then followed by Friederike, she will guide us through the scale-up process, not only the scale-up process when thinking about like battery production, but in general is the process of scaling up. And this is a really important, difficult process. So I'm really looking forward to Friederike, of what you can tell us about it. We then switch to up north from ZNL Energy. Jan will give us an overview of what separators can do in batteries and why it's important to also include separators in your innovation of the battery. Then Dominic, I hope he can manage to join us. He had some problems, but he will guide us through the really difficult, not difficult, but important topic of thermal runaway and also how to analyze it. And then last but not least, Garrett, the CEO of Scalium, will talk about the important but also difficult process of lithium metal anodes. Before we start with the pitches, three really important things to keep in mind. First of all, please keep your microphone muted so we are not disturbing the speakers. And use the hand sign if you want to ask a question. We then ask yourself to unmute when we switch over to the discussion part, which is coming after each pitch. And last but not least, use this format also to start connecting yourself, to start networking. So feel free to post your contact details or any other questions, of course, in the chat. And Simon, I think with this, we are ready to actually start with the first speaker.
All right. So first one, as Max introduced, is Benjamin Blat Belmonte. He's the founder of Fenexity. Benjamin, you have a mechanical engineering background, but are going to talk about enabling grid-aware smart charging, operational flexibility for battery integration. Well, that is software, right? So maybe you can explain a little bit on how a mechanical engineer starts a software company. So stage is yours.
Yeah, thank you so much. So let me share my screen because, as you said, it's quite a shift, and I hope I can convey the process and the motivation and the reason why I'm doing this. And let me set the timer so I don't run too much over time, but I'll start right away. So Fenexity, thank you very much for this opportunity of the battery spotlight. You will only see the word battery once, so let's see if you can spot it on the slides. But one thing I've come across recently very often is vertical integration. And I think by the end of my presentation, you will understand what I mean with vertical integration. So Fenexity does smart charging. What is smart charging and why do we need it? We focus on heavy-duty electric vehicles, which of course have a battery, such as trucks and buses. And with smart charging, we mean many things, but mainly we mean to reflect the prices of the energy system, especially the renewable energy system, which is driven by high volatility. We see here the characteristic day-ahead price curve with peaks in the morning and in the evening. And what happens with regular fleet operations, for example, with a bus fleet, is that you charge right when it's expensive and you charge at the same time, which leads to peaks, which also is expensive because you have to pay grid fees. So it's quite the suboptimal state. Then, of course, the next thing to do is to build an algorithm, an energy optimization mechanism that shifts charging to low prices and also serves peak shaving. So that is the main idea. There are many things running in parallel and on the background, which I will not dive into yet. But the beauty in this is that by saving money, you also reduce the carbon footprint because you mostly will be charging clean energy. And I will not be talking about algorithms, but I want to show you the face so you have seen what this actually looks like in operation. And for a fleet manager, he does not have batteries. Maybe he has a stationary storage battery, but he has vehicles to manage. So he needs to set maintenance, set the disposition, and also set the charging profiles for its vehicles. The end goal is to automate this to fully extent. To the people familiar with smart charging, OCPP is an abbreviation you might have heard of. So what we are building is OCPP license based on the open source framework of the Linux Energy Foundation. It's scalable and hostable in the cloud. So battery electric vehicles. Vehicles are mainly for driving, but what is so special about batteries and why am I today in the battery spotlight? Because I want to maybe trigger some people in the audience on a few things which you are probably aware of, but which is very important for us who are trying to create and develop smart energy management systems that heavily rely on battery characteristics. So why are batteries so good? Because they have fast reaction times. We can do primary control reserve. We can do arbitrage. We have very tight control of the power consumption. And if we think towards bidirectional charging, also the provision of energy. And our new clean energy system definitely needs a lot of storage flexibility. If we achieve to unlock this flexibility by setting the right software interfaces at the battery management system level, we enable vertical integration, which means we enable to provide this flexibility to the whole system. And with this, I come to the last slide. This is us, the founder duo, David and me, with experience in software development, also mechanical engineering that soon moved towards the energy systems group during my PhD. And we have a lot of experience in that regard. And right now building the fleet management system, also energy management system. And if you want to connect, feel free to scan the QR code. I think I have slightly overstepped my time, but glad to answer any questions so far. Thank you.
All right, thank you, Benjamin, for the interesting presentation. So first question, as always, is there a question from the audience right up front? Don't be shy. I think there are many hands, or no, they are just clapping yet. Okay, good. So let me ask you, who is your customer up front? Do you have any on the roadmap that you have ahead of you? Any specific companies or that you could name to anticipate the business case a little bit better?
Yeah, so the ideal customer profile for us in the phase we are right now is a fleet of, let's say, between 5 and 50 vehicles that are either going to electrify or already electric, which means there are some complexities in the disposition, the route optimization, and all that has to be entangled with the energy management system.
Mm-hmm. From a technical perspective, what would be the requirements, the prerequisites that you would need in order to get operational with them? So are there any specific requirements on the software side, but also potentially from the hardware side that the customer needs to be aware of? So
maybe not, well, the customer probably has not too much experience with charging infrastructure himself, but the partners, we need to, of course, have close discussions with the partners to align on the interfaces. The software systems at the client side, which are of most interest for us, would be things like disposition, schedule planning, schedule services, so that we can get the information of availability and energy need from the vehicles and place that into our algorithm. Thinking towards the future, what we need on the battery side of things is communicating to the vehicle controller, which in turn communicates with the battery energy management system. But we are not going too deep on that side, but we rely on the vehicle OEMs to build systems that enable us to access this flexibility. Yeah, thank you.
Mm-hmm. All right. Okay. So I think then I have a good understanding of what your innovation is about. And as you said, it's not a particularly battery-centered business case, but it certainly uses the battery as an integral part in its solution. Max, you're raising the hand. Go ahead, please. But you're muted.
Thanks. I actually have two questions, both regarding the business case. The first one is, at the present, I just read that that there's a first offer in Germany where you can integrate your car in such a smart grid storage or like your, what do you say, virtual power plant, and they pay you about 800 euros for this. And in the interview I read, the question was asked like how much money is actually generated by having a car integrated in such a virtual power plant. Do you have any maybe numbers or an idea how much you can right now make with adapting your car in such a virtual power plant?
To be honest, I don't have a clear number. I know the ecosystem is ramping up after many years of the research department pushing bidirectional charging and leading the regulator to enable these kinds of business cases, removing double taxation and grid fees. But what I can tell you is that there's a huge potential for this business case, at least from a theoretical standpoint, because that's what I have done with not cars, but buses. I have taken a look out at the Darmstadt, so the city I'm living in, Darmstadt electric bus depot as a whole, and compared or analyzed and optimized the electricity cost optimization at the short-term electricity market, which is exactly what these kind of business cases with V2G rely on. And to keep it short, it turns out you can, in some scenarios, reduce your electricity cost to basically zero. So there's definitely a huge potential.
Definitely a benefit to think about it. Maybe a last question, and then we definitely have to move over to the next speaker. But is that a business model which will be viable in the future as well? I mean, the more storage capability or capacity is in the market, the lesser the fluctuation of the prices are, and the less money you can make with this. So is that a business case still viable in like 15 years?
That is a good question with a very long time horizon. In my personal opinion, I think there's always going to be volatility in the energy price or energy system of some degree for whatever reason. If it's not generation, then there might come other reasons from consumers that need energy at specific points in time. So I think there is always going to be the need for energy flexibility, but maybe that's just my personal take.
Perfect. Thank you for the short answer as well to a really tricky question. And Benjamin, thank you very much for
Thank you.
your insights. And we move over to our next speaker. And I'm really happy to introduce to you Friederike Bohm. She is the founder of her own management company, and she will tell us today about or we all know that scaling up is an important process. It keeps the prices down. It makes the market entry or the selling of your products viable, but also it's really expensive, and you get the benefits only in the end when the scaling up process is done, and then all of your money is invested already, or let's say gone. And therefore, it's really important to consider the first steps before planning the scale up. And yeah, with this, I'm really happy, Friederike, to have you here with your long experience in this field, and I'm really looking forward to what you can tell us.
Thanks for having me. And today I'm going to show you Pilot Plus, as you said, a structured approach to turn transformation in the battery sector from pilots into scalable operations. And in order to explain what that really means, I will first outline the underlying issues in the battery sector, then show you the solution Pilot Plus, because it didn't start as a framework, but emerged from VUCA real-world challenges. and finally show you how this translates into real-life use cases. So this is certainly nothing new to anyone here, the reality of battery transformations today. Technologies shift faster than strategies can adapt, regulations are fragmented across borders, supply chains operate under conflicting governance systems, data standards compete against each other instead of converging. So we have 5 moving targets at once, making batteries one of the most VUCA-shaped sectors today. And conventional project approaches systematically fail in this environment. Whether there are isolated pilots or big bang rollouts, they cannot orchestrate this complexity. And many brilliant startups like you today pitching your innovative solutions here in software and hardware might have recognized that between the first adoption and industry-wide adoption, there are big gaps remaining. Gaps nobody is solving systematically at the moment. So what is missing? What's the alternative? And of course, it is Pilot Plus. It was designed exactly to close these gaps. It wasn't, as I told you before, built top-down in a workshop. It emerged bottom-up from years of transformation failures in automotive, supply chain, and batteries. And from a bird's eye perspective, I always saw the same pattern repeats. Pilots succeed maybe tactically, but fail strategically because they're not aligned with scaling. And the recognition here was there's a common core problem, so we created a common core solution. And this is a stable structure, which is the same across all phases, from pilot to full rollout. And we all always say it doesn't matter which framework you prefer, it's always the same questions we are asking. And the key here is in first pilots, you need only to answer these pragmatically and in later stages in different depths. We call this the maturity to target bridge. In a nutshell, this means we have one constant frame and no constant reinvention, which saves a lot of time and money in the process. And who coordinates all this? Of course, again, Pilot Plus, because the framework is made to reduce complexity first, and then orchestration becomes possible too. And this means customers, everyone within the project gets tangible next steps, doable, and consultants and tech enablers can focus on priorities, adapting to the customer's specific needs, and have time to enable the team on the way. And why is it so important to grow internal maturity alongside? Simply spoken, customer support is needed from beginning to build pilot readiness, let alone rollout capabilities. And tech partners alone cannot deliver that. And in addition, a transformation, as we all know, isn't a one-time project. It's an ongoing initiative. So constant external dependencies isn't sustainable, simply too expensive. That's why we built in change enablement, trainings in each phase so you can build your internal capability to your own scaling. And why we are asking ourselves all the time for you, what's the sufficient next steps? You are probably asking me right now, okay, gaps closed, but one thing is missing. How does this actually become a product I can buy? And this is why we have created ready-to-buy transformation packages together with tech enablers that include our modular mature as-you-go approach. For example, battery passport, Catenary-X, fleet and charging, just to name a few. And each package appears standard on the surface because the duration of the phases are the same, and each package follows the same operating system I showed you before: analyze, implement, optimize, and scale into resilient operations. But where it gets different is that we might sell a finished product, but it remains fully modular inside. We run a short workshop with you to get to know your specific maturity and constraints. Then we swap the use case models precisely in scope and out of scope for now. And the course framework stays identical across all configurations, but the building blocks adapt to where you actually are. And this means you don't have to coordinate the tech partners. We are doing that for you. And most of all, you are not forced into a one-size-fits-all offer that ignores your company's readiness level. We make 100 small decisions to make this possible, so you don't need a 50-year strategy up front. We build a strategy with you that's deliberately designed to scale later. In summary, we recognized same transformation challenges, same constants over the process, but different industry missions. And I'm sure the chaos will always stay the same. And this is why we built Pilot Plus, to orchestrate what others can't. And we are addressing gaps here. The industry is finally waking up too. And this is why the big momentum is coming so much from the battery sector right now. And I'm so grateful to be here and to announce that pricing and first packages will roll out in the second half of this year. So if you're an investor looking for the battery space, this is an operating system scaling into a growing market. If you are a consulting house or tech enabler, let's talk about co-creating a package that combines your solution with our orchestration. Or if you, of course, are a customer and you want to stop the pilot chaos and start mindful transformations, we are ready when you are. So please feel free to scan the code. Have a look on our website. I'm happy to talk, and because there is so much more to Pilot Plus than just a 4-minute pitch, I want you to attend the follow-up webinar I'm hosting on the 14th of April to show you a deep dive into Pilot Plus and the first packages. Thank you so much for listening.
All right. Thank you for the overview. And yes, 4 minutes go over really quickly, and we are a little bit over time. But if there's that's okay. If there's a question from the audience, just please raise your hand and unmute your microphone, and you can ask Friederike directly. Otherwise, you already mentioned that if there are questions emerging later, they can always attend your seminar and get the question asked done.
I will send you all the links in the chat to the webinar and my contact data and everything.
Perfect. Then let me just allow me a really quick question about what sizes of the scale up you would be like the perfect match for you. Are you like helping with really small scale ups, or is there a limit where you say no, that's too big? We can't really help there because it gets too complex.
Oh, very good question. Because in our Pilot Plus strategy, there is scaling up is planned until 2 years. So we plan like a small as SME is our focus target group. So we are looking for smaller scales, but at the moment we are talking to big consultancy companies and big companies for platform and cybersecurity topics in order to be able to make it possible to scale up to a really big scale, like not only one site, but whole company wise, or so that you are able not only to scale for one process and then one site and then the whole company. We make this possible. So it's the scale is growing right now, but it's a 1 or 2 year target. We say first pilot when example cutting eggs, 8 to 12 weeks for the pilot, second scaling phase 6 to 12 months, and then another 1 to 2 years in order to be a resilient operation. And we are trying to make it possible for even bigger transformations in the future because we know it's needed.
All right. Thank you. Yeah, thank you very much for your presentation. And I think we have to switch over to the next speaker.
Thank you. Thank you very much.
All right. Yeah, and this brings me also, Friederike, thank you from my side. This brings me back to memories I had last summer when I went to Norway with the battery expedition and met Markus. I think you're on the call as well, right? Shout out to you. But today, your colleague Børge Sagmo is, who's co-founder and chief strategy and marketing officer of ZNL, is having the stage here to present the innovation ZNL is pushing. Talking about separators here, special separators, which are a little bit different from the things that you can buy normally. But without further ado, I think I hand over the mic to you, Jan.
Yes, thank you so much. Just let me start the timing so I don't go over so much. So thank you for the invitation. I'm going to talk about ZNL Energy and the next generation separator called ZNL MPX. So there's a problem ready to be solved when it comes to batteries. It's poor fire safety, it's low lifetime expectancy, and of course, low energy density. And the cell maker's trade-off challenge. If you optimized on fire safety or energy, then you often have to.
Sorry, Jan, I think you have to switch to the
Oh,
other
sorry.
screen.
How do I do that? Why is that happening? That's a little bit strange.
Yeah, doesn't matter. We can read it.
I was. How do I switch the? Oh, there you go. Is it better now?
Yep, it's full screen now.
Yeah. Okay. Good. I'm gonna go back to. Sorry. So the modifying two parameters is relatively straightforward for cell makers. However, adjusting parameter involve trade-offs between cycle life, fire safety, and of course energy density. So the ZNL MPX is tackling this compromise head-on. It's important to understand that we are a drop-in replacement, meaning you don't have to re-engineer your factory or your battery cells to use our products. We are doubling useful lifetime because of the way the separator is produced, and we have enabling higher energy density, and of course, we eliminate fire. So the market at a glance, the McKinsey report says that largest battery value chain white space in Europe and US because it's only 3% of all separators manufactured in the world today comes from Europe or US. So when you have battery projects going on in Europe and US, one of the key components, it's still bought either from China, Japan, or Korea. So home sourcing and geopolitical thing can be an issue if you want to home. And the Industrial Accelerator Act that just came showcase that you need key components in Europe. So what's the difference between the conventional separator and ours? The conventional separators are porous, meaning they transport the ions through microporous structures and electrolytes. Ours is a PPS, it's non-porous, meaning it transports the ions through something called diffusion. There's a crystalline structure inside the PPS where the ions transport, and only the ions that you want to transport, even if it's lithium ions, sodium ions, or zinc ions. We also have a PE layers on the anode side. If you have a thermal event, that will shrink, but the integrity of the separator will withhold because of the high melting point and the shrinkage that we have on the PPS. You don't expose the electrodes. What happens in conventional separator when there's a temperature event, it will melt and you expose the electrodes. We also did an exciting internal test where we took iron powder on a NMC 811 cell on the cathode to simulate what happens during contamination. The conventional separator battery cell couldn't even take a charge. It just short-circuited at once. With our separator, it just kept no worries and it went completely fine. We also have external tests. This is from a sodium with 4 voltage. And you see the orange and the scattered, it's the conventional separator. With ours is almost at 100%, and it's really, really even on the cycling. So we lasted over 900 cycles. So this is on the next level chemistry. We also see similar test in high NMC 9XX from a US player where we doubled the lifetime of of the battery. So we're in the positions. We are a separator producer, so we are right before cell assembly and cell production. We make advanced polymer-based separators. We are not a battery cell or a systems provider. We offer safety, durability, and longevity, and the team is based in Norway. Thank you.
Right. So, Jan, thank you very much. Very elaborating and inspiring. First critical question is, why saving energy density? Because this is a passive component in terms of energy storage. Can you elaborate on that?
Yes, so basically, if you want higher nickel in a high nickel NMC, the higher the nickel content you have, then you will have a nickel shuttling or manganese migration from one side. So you're poisoning the battery. Since we are non-porous and tight, you don't have that nickel shuttling effect or the migration of the manganese. So you can have it, because the goal is in an NMC is to have as low as possible on the cobalt side because of the ethical part and the mines in Congo, and of course the manganese. Same with lithium sulfur. So we are enabling the battery cell manufacturers to have higher nickel or lithium sulfur or high voltage on sodium.
Okay, gotcha. And second question to you would be on the business case. I mean, and I learned during my visit already that this is a really high potential technology that you have there. The question is, what is the market application that you look at? Who are your customers? Because likely the innovation also comes at a price point, or?
Yes, we of course you can have the best product, but you price yourself out. Nobody wants to buy it. Right now, I developed something called a test agreement. We are right now at 40+ test agreements with different type of OEMs, battery cell manufacturers from Europe. We actually have a European player that just did the industrial pouch cells and have ordered product for the A level cell. And we have American-based OEM that has been testing with really, really good results. So the price point that we are looking at is the same as in the EV. So also, if you have CellGuard's high quality separator, we are competitive on the price on that. Our goal is basically to set up a separator factory to manufacture separators to either Europe or US.
Okay, so you have an ideology, not ideology, but you have a focus on the market sector. Okay, gotcha. Yes. All right. So Dominic, you have a question, right?
Yes, thank you for the really interesting presentation. You mentioned that you eliminate fire. Could you expand a little bit on that? Because that's a big claim.
Yes, you can actually look at a LinkedIn video that I have with 8650 cell that Tesla used to use, where we penetrated that with a spike and no fire. Basically what happened is, if you look at this slide, you see when you get the thermal event, see for instance dendrite formation or a thermal event, because of the PE or the PP melts down and shuts the ions. So we see on test that we go up to 80 degrees where the glass transition or the melting points of the PE, and stops the ion. So it goes up to 80 and then it just drops. So you don't get the uncontrollable thermal events.
Good. Yeah, thank you for the elaboration. And unfortunately, time is up already. We're 2 minutes behind even. So I hand over the microphone to you, Max. Let's continue.
Yeah, thank you. And I think it's already a really good transition to the next speaker who actually asked the question. And so let's keep on the topic of thermal runaway. And I think it's a really important topic because it's also one of the biggest concerns we see in the public and also the public opinion of batteries, because nobody want to have a thermal runaway independent of the application. Let it be the car or the battery storage system you have on your balcony or in your basement. And therefore preventing but also analyzing and understanding thermal runaways is really important. And Dominic, I'm really happy to have you here and looking forward what you can contribute in understanding, and then maybe preventing these thermal runaways.
Awesome, cool. Thank you very much for having me today from home office. So we're going to spend the next 4-ish minutes, I hope I don't go over time, talking about how we can build better and safer batteries using the insights we can obtain from thermal runaway calorimetry. Like you said, Max, it's really, really good to prevent thermal runaway no matter what the application is. So we're going to have a quick look at thermal runaway in general. What is it? How can we describe it? We're going to look at why exactly it makes sense to prevent it, even when there's not a clear certification requirement that forces us to do that. We're going to look at our 𝗕𝘗𝘗𝗃 method, what type of data we can obtain from that, and example data. And then we're going to look at use case and finish with Q&A as always. And to get going, let's just have a quick look at what thermal runaway looks like. I'm going to show you a quick video of 2 𝗕𝘗₄ cells. Those are the ones that are used in the Tesla Model Y. In the actual car, they're about 800. Here it's 2. They're fully charged. I hope the video works and you can see that well. You can certainly see a lot of energy being released, a lot of gas being released, and a lot of mass being ejected from the cell. Those 3 properties will be important in a second. I think it's pretty self-explanatory why it's nice to prevent this from happening, but there are 3 objective good reasons for that. The first one we already mentioned, it's certification. If you want to release a car, you need to go through homologation. If your car isn't safe according to the standards, you can't sell your car. The second is ethical. If you see the picture here of a screen grab from a Air China flight where a battery caught fire in the overhead compartment, I wouldn't want to be the battery designer or owner of the company that built that battery when that happened. Thankfully, everything was okay, but could have gone much worse. And the last one is a big one because it's commercial. Like if we release a product into the market, it's our responsibility to make sure it's safe. So even when there are no super strict propagation containment requirements like an automotive, dealing with a product recall or an insurance claim can be very, very costly. So it makes sense for everyone who builds batteries to factor in safety into their development. And the best time to do that is early on when you still have a lot of wiggle room. This is why we developed 𝗕𝘗𝘗𝘃, long acronym. You don't need to know what it stands for. What it does is it allows us to fingerprint cell safety behavior. We can essentially quantify the safety of a cell with a single measurement to understand how it like behaves objectively. We measure the total energy that we discussed earlier. So how much energy is actually released by the fire, by the explosion. We determine where that energy is released. Is it ejected from the cell or does it stay behind in the cell and leads to a heat up of the cell? We determine how much gas is generated by the reaction, the rate at which it's reacted, how fast the cell reacts, mass loss, and a bunch of other properties that I don't have time to get into. I brought a quick example here. This is from cell selection. We have 3 manufacturers of roughly the same cell according to the data sheet. It's a 5 amp hour 2170 cell. 3 manufacturers, China, Japan, Korea, not in that order. And we triggered that runaway in our method. We're going to look at the energy as an example, and we can see that the total energy released by the fire, by the explosion, is roughly the same for all 3 cells. But when we look at how it is released and where it is released, we can look at the cell body energy fraction, we call it. So that's the energy that's released in the cell itself and leads to a heat up of the cell and a heat up of adjacent cells. When we look at that data in detail on the right, we see that the cell from manufacturer 3 releases about 13-ish kilojoules of energy. The cell from manufacturer 1 releases about 20 kilojoules, so roughly 30% more. That means if you have an application where cell-to-cell propagation is a huge issue, small cell spacings, like high requirements on weight, it might make sense to go with cell 3 because you'll have an easier life designing a propagation-safe design compared to cell 1. In general, this information is useful everywhere where we compare cells to one another, like in cell selection, or where we need to understand cells in a lot of detail. So we touched upon cell selection. We actually also do a lot of work with cell developers, where we track if the cell safety changes through generations of a cell. You go, like Friederike mentioned, through scale up. Does something change to your safety behavior as you produce more cells? It's also very, very helpful for edge case behavior. A common one is lithium plating. A lot of people at some point ask, holy shit, what happens if my cell plates? Does that change my safety behavior? We can run our test on pristine cells, on plated cells, compare the behavior, and then we know where to look and if we need to change something in the design or not, so be active essentially. Speaking of design, that's the last big application field. We have really nice quantitative data on the thermal behavior of the cell and the gas release. So we can just do proper design using empirical data, like, for example, sizing thermal management systems. Super quick summary. I'm looking forward to your questions. Thank you.
Thank you very much, Dominic. So if there are questions from the audience, please put them in the chat, raise your hand, use your chance to talk about this with Dominic. I have the first one, actually. Maybe it's a little bit like picking words, but one of the headlines was lithium batteries for bicycles are the fastest growing fire risk, which is not equal to a high fire risk. Could you maybe comment, like maybe also compare it? I mean, we always have dangers, like cars can burn as well. Could you maybe give us a crude overview of how dangerous are batteries right now? Like looking overall, not on the specific cases where they went crazy, but the occurrence of these accidents.
Sort of the failure frequency. I can't give you like exact numbers. I'm not an expert on macro battery recalls. I can tell you that Sony recalled laptops because 1 in every 200,000 laptops exhibited different thermal behavior than normal, which means that 199,000 and something laptops were okay and still had to be recalled. Anker just recalled products, Volvo just recalled cars, Volkswagen just recalled cars. Like, it's a very, very common occurrence, even though I can't give you exact numbers. It happens like all the time.
All right, thanks for that perspective. And Simon, you have a question.
Yes. Going back to when I worked at RWTH and had at eLab, we also had a battery testing facility. And the critical question was always, how many amp hours do you get put in the chamber there? And that's the critical question to you, Dominic. So how much amp hours can we do until the doors pop open?
Really good question. So we can do about 100 amp hours if we want to include gas analysis. We can do about 300 amp hours without gas analysis, because the gas analysis equipment wouldn't survive the extra amp hours.
Okay, good. But that's so for all the startups here who want to test, now you know how big your cell can be. Good. Yeah, thank you. All right, Max. I think in terms of the time, I take over the mic, right? So
yes, please.
Dominic, thank you very much. It was very interesting. And yeah, so now we come back to the production side. So going way up the battery value chain again. And yeah, which also brings me back to my time in Aachen and to an old colleague, and that is 𝗕𝘁𝘁𝗿𝗆. And back in the days, we were there at our lab talking about additive manufacturing of battery cells, which is also where I'm coming from originally. And he took this idea way further, and by now funded Scalium, which is looking at production of metal anodes for solid-state batteries. So Gerrit, without further ado, I think stage is yours.
Yeah, I would say, so from 3D printing, we are now way far apart. I will leave this to some shady startups in Saxony. Nevertheless, we focus on the enabling of scaling lithium metal electrodes in the manufacturing process. And if you look into batteries, I guess we learned today a lot about ignition of cells and everything, but what's inside is more or less on the anode side, mainly graphite. So somebody's talking about some silicon anodes, but if you look into the status quo and into the world of batteries, most of the time it's graphite. And so therefore there is no leaps in energy density possible anymore. And we nearly reach to go to the next steps. And when we do this, and when we look into the emerging solid state startups, mainly in the US or in the rest of the world, they're all focusing on one component, which is lithium metal actually. So in theory, lithium metal has 10 more times capacity than graphite. And also, when we look at the supply chain resilience, lithium is way more distributed around the world than its graphite, and it's way easier to get out of China or to get it, maybe from Portugal or something like this. And as mentioned, so solid state batteries mainly focusing on lithium metal or solid, or the solid electrolyte is mainly the enabler for lithium. Depends on how you want to frame it. What we actually do is we manufacturing the lithium, but also we cannot use it only for solid states. We can also use it in a different way due to our process. The current process right now to produce lithium metal electrodes is on the one hand, extrusion and lamination process, and on the other hand, it's a physical vapor deposition process. So we have, on the one hand, the very good commercial ready electrodes, but you have a thickness of 50 to 100 microns, and this is way more than you actually need. And on the other hand, you have the lithium metal, which is deposited by vapor, and you can imagine that the vapor deposition is very, very slow. So it's also limited in scalability. And scalability is most of the time a buzzword that everybody just throw into the room, and so nobody asks about it. But what does this actually mean? So it's not scalable. So when we look into 35 gigawatt hours of a European production plant, or what was more or less the standard production for Europe for 2030 in the past, with an average physical vapor deposition equipment, you need 744 machines above for producing the lithium metal electrodes for this, which is around 1.3 billion of capex. So therefore, I would say we can put a tick behind it that PVD processes are not that scalable. So for this, we developed a liquid application of lithium. So we use molten lithium. And we coat this on a substrate and use temperature-induced in situ reaction to build out such a 3D network inside, which also helps us not even to use alloys or have this 3D skeleton inside, but this 3D skeleton actually increases the bonding of the material, so we don't have problems with lamination. It also prevents actively the dendrite growth. So therefore, we have a way more even distribution of the current, and therefore we are able to produce higher cells or bigger cells, and also we are able to use this material to build next-gen batteries with liquid electrolytes, not mainly solid-state electrolytes. So for this, we can be the enabler for leapfrog when we can actually make this process scalable, and this is what we are working on right now. So there was quite a rush. Nevertheless, we are based in Aachen. If you have some questions, feel free to ask.
All right, Gerrit, thank you very much for the elaborating talk. Are there any questions up front? If not, I have a technical one. On the last slide, you had the current collector of 12 micron. Could you go thinner with this? Because the current state of the art is way thinner, right?
Yeah, so the current collector, of course, is more or less 6 microns when you look into the industry, because we use the temperature-induced reaction between the copper and the lithium. For example, currently we prefer a thicker one. That we don't bring a hole inside.
Sure.
But with the lithium, we can go, or our last electrodes that we produced had a thickness of 3 microns. So therefore, also just give us thinner foil, and we can use this as well. It's not a big issue.
Okay, understand. And from the entrepreneurial point of view, in your technological development, but also from the business case and scaling your technology, where are you to just understand what are your next steps? And
Yeah, so currently we are more or less in the funding stage, so that we now can ship samples to customers. So we have a production plant ready and we are now scaling to a width of 50 millimeters. So yeah, right now we are able to then produce single sheet pouches with 50 millimeter width of the electrodes, and but right now we're quite confident with 25 millimeters. So we mainly focusing now on coin cell development and improvement on this side. In the next days, or we mentioned end of this quarter, we will be or customer ready. And then we will start shipping lithium chips on copper, and also customer solutions to our pilot customers.
Okay, good. So very promising, and yeah, great success. Really inspiring story.
Thank you.
So Max, Mike, back to you. You're muted.
Thank you very much. I think with the time we come to an end to this session. Actually, there are some more questions in the chat haven't been answered right now. I mean, to this, but also to I know there were some questions before which we couldn't give time to be answered. Use the opportunity to. I mean, we posted all of the LinkedIn contacts of all speakers, so you can address your question directly via LinkedIn to them if you still want to have an answer. We will keep this room open for another 10 minutes maybe as well. So if you have some questions and the speakers have time to stay there, use your time to address the questions afterwards. I just want to take this time now to thank everybody, all the participants, but of course the speakers for their really nice presentations and insights. And I want to quickly share my screen again to give you two more important informations. You can see the screen, I hope. So first of all, we do this every month. Most of you already know that if you want to register to the next event, Julian is already posting the session. You can directly apply to our next session. And yeah, the next session will be March 19, the same time, 4:30 p.m. in the afternoon. Also, another important thing I want to mention is if you like the format, if you want to present your company as well, because you have a good idea, innovation in the battery ecosystem, then feel free to contact us and we will see where we can find you a slot as to participate as a speaker. And since our funding from the German government, participation is free for all listeners, but also for the speakers. And with this information given to you, I again thank you all very much for participating. I wish you a really pleasant afternoon. And if you have more questions to the speakers, then use the next minutes to discuss it. And otherwise, see you hopefully next month.
So thanks from my side, and yeah, have a great one.
Thanks a lot for organizing this.
Thank you very much.
Thank you, Dominic.
Good job, guys.
Thanks to everyone.
Thank you so much.
See you, Marcus.
See you.
See you, and bye.
See you next month.
Yeah, we'll do.